here. Just got my COVID shot, my first COVID shot today. So hopefully I will survive the stream, but I'm very confident that this will be the case. And today we will be talking about automated testing in Pinball, or in the Mission Pinball framework, or how to test your pinball machine using automated tests. What we will talk about. And I prepared some motivational slides. And afterwards, we will just explore how this works in the real machine. So we will take my machine, which is already running in the background here, and we will have a look on how this will work, how this works, and we will write some tests for the machine and have a look at like some modes. If you got questions, if you got ideas, we can do that basically on the fly. I guess we can do everything. Not an issue. This is somehow my machine. Should I keep it running? Maybe I will just restart it. It will run. Yeah, so something happens. It's my machine in the background, showing some nice DMD animations, and I will explain this later a little bit. Yeah, so awesome. Let's get started. What do we have? So we're talking about automated testing in Pinball, and this needs to, so and there basically has to be a reason for that, and that's basically the first point in our agenda. So why exactly should I write tests for my pinball machine? That's not, that's probably not obvious to everybody in the beginning. And I will ask some questions, some rhetorical questions, and you probably can guess the answer. And then basically, what can we actually test? So not that we can test like everything, but we can test a lot of stuff in our pinball machine. And we will go into like some crazy computer science theory in the beginning, but it's simple. And then we will explore the possibilities. And afterwards, we will just jump into my machine and write some awesome tests for it. So let's start with, why should I test? So imagine the following scenario. So you write some mode for your machine. So like you write like a mode where you have to shoot the orbit 3 times and then shoot some ramps, and then something happens. And then usually what you do is you spin up the machine, try a few times until it works eventually. And why would you need a test? That's, you verified it, it works. Why do you need a test? And then let's imagine you're at the second mode. So like you now have got like, you shoot the right orbit 3 times and now something else happens. And you shoot left orbit, right orbit, left orbit, right orbit, left orbit, for example. And you can now verify again that the second mode works. But now the question is like, for example, if your second mode contains the left orbit as well, then does that trigger like your first mode doing the second mode? Should it? I don't know. So you have to like decide on what you want, and then make sure that it actually happens this way. And that's actually one of the points where tests help you to make sure that stuff keeps working in a certain way, right? It's just not that it initially worked this way, but it also just keeps working this way. And if you imagine like more modes, it becomes harder and harder to make sure that they do not interfere in unexpected ways and that they keep working. And I mean, later you ship your machine to some testers, or you just play it on your own and you find a bug, and that might be like a few months later. And usually, yeah, you go into your code, you fix the bug, and then what you do is like you start the machine, you enter the mode, for example, in the MPF Monitor, and test it. See if it actually works now, or if it's broken. And usually that takes like a few iterations, and every time you start up the machine, add balls, start the mode, and then try to trigger the bug. And that's tedious in a lot of ways, especially if it's like if you got deeper rules, you always have to like reach this point where this bug appears. Sometimes you can like shortcut it by having some key bindings to shortcut like the mode start mechanism in tests, but you still have to do it. And one of the way to prevent this from happening is like having a test. We will have a look in a minute how this will work, because the test can do this like a lot faster than you can do that, and that might help you to iterate faster when fixing bugs, for example. And finally, also like the thing is like you have to upgrade MPF from time to time, or you probably want to upgrade MPF from time to time. And now you probably want to verify that all your modes still work. And if you want to do this manually, that's a lot of work every time. Then you would like probably only update like once in a year or something. But if you've got tests, well, upgrade MPF, run the tests. If it still works, fine, keep the new version. If not, you know exactly what's broken, and you can try it on those issues. So that's basically the advantages of tests and my sales pitch here. So next on the agenda is like, what can we actually test? And I brought a little bit of computer science theory here. It's not very complicated. And if you had any CS classes, you probably know that picture. And it's basically how you like unit or integration test stuff. It's like you got a certain set of inputs. You got system under test. This is your pinball machine, or the software of your pinball machine here. And you got a certain set of outputs. And now you want to make sure that like the stuff in the middle behaves predictively. So with the same input, you should always get the same output. So you need to try to remove all the randomness inside this box. And you have to you choose your inputs and outputs, which is probably not obvious in this case. So like you've got like, I don't know, some logic circuit that's simple here. You have signals in and out, but in the pinball machine, it's not that simple. Or is it? I don't know. Let's see. So in a minimal example, so what's the input from a player? The input from the player is just some switches. So like you hit like the flipper buttons, those are switches. The start button, this is just a switch. And the ball also just hits some switches. And that's basically all the inputs you like minimally need. Or you need to simulate a player, basically. You're simulating the inputs based on the player. And the minimal outputs we need for tests are like all the coil actions, so which coils actually are triggered or activated or enabled, and like, or maybe also like which lights are active. That's useful in a lot of ways just to see which modes are active. I mean, you somehow have to tell how or if they are active. And then like which sounds or slides are which sounds apply, which slides, or what is shown on the DMD or on the LCD. That's in MPF, that's slides. That's basically what we minimally need, and we definitely can do that. And in MPF we can even do like a little bit more, and that's this. So as an input we can either put in like switch changes, but we can also like post certain events. So like if you want to trigger certain logic inside your game, Then you can also directly post certain events, and that might trigger some logic, and in some cases that's useful. You can also call directly into any game code if you got custom code, if you just want to test deeper stuff. And one tiny little thing which is super useful is like we can time warp. So we can say, well, now let's wait 1 virtual second, and that will only take a blink, but in game time it will be 1 second or 10 seconds or 100 seconds. And that allows us just to run the game faster than in real time. So like even if the activating a mode would take like 10 seconds as a player if you're good, in a unit test or integration test, that's just like a few milliseconds. And like the outputs or what we can assert on, that's also the coil actions, lights, sounds, slides, but also like placeholders. So we can use like placeholders which you usually put on slides in your pinball machine, and we can assert that they got certain states. So you can say, for example, this the state of your state machine in your machine, or the count of counter or something, and that's something we can assert via placeholders. We can also just assert any internal state of MPF via like calling into Python code, and we can also like run code, any arbitrary code if we want. But with placeholders and assertions based on internal state, we can just check a lot of stuff. I will show you in a minute, basically. So if you had questions, let me know. Otherwise, it's demo time, and I will show how this basically works in my machine. So my machine is already running here on the right, and we can now also like example of match mode unit test. Yeah, we can do it. In my machine, it's an issue because I do not have a match mode. But let's go with a simple example, and then yeah, maybe we can grab some other machine and do it on that machine. So that's basically here running. That's my machine running here. Yeah. So this is the media controller, and that's the monitor. And now what I want to do with you is we will now just play the game once and then see how we can automate it, what I'm just about to do. So to play this game, first we need some balls. So let's just add some balls to this trough here. And now it will balance those, so it will shoot one over to the other side, because it's a head-to-head machine and it needs one ball per side. And now next is we need to press the start button. It's simple, but if you don't do it, you won't have a game. And we can do that, and the game will start. It will have some sound here. We'll turn down. And now the game is running. We got like one ball here per player. It's basically a feeder. If I lose a ball, it's feeded from here. And one ball is on the playfield, which is also shown here. Like this is how many balls the player has on the playfield. And now, for example, I mean, you see those indicator arrows here. So it indicates that I can shoot those ramps or orbits. And for example, let's go with the left orbit here, shoot it once. Now it's flashing here. This one is lighted up. And I can do it again. Now the third one is active. And I can do it another time. And now basically the qualification of this mode starts. And I can shoot this shot. So We can choose this one or any of those two. On this again. And now, and now this mode is completed, and the other player will be basically blinded, so all the lights turn yellow. And that's basically what this mode does. And now, after a few seconds, the other player will be unblinded again. And yeah, I mean, the idea now is to test that this works with the unit test. Because if I wanted to test this, I mean, that's quite a sequence to do this manually. So how we do that is like we write a test. And I started this a little bit. There's like the MPF Machine test case. That's what you want to inherit, to have a test case in your machine. And you put this basically inside your machine folder. I put it like a machine test folder here. And I got a few tests already, and then I got like test stream. That's the one I'm doing now. And you can run it with Python and unit test, and then machine test dot test stream. That way I can execute machine tests, it's plural. And now the test ran. So that's how you execute tests. That's basically why the MPF, the Python unit test framework. And I can also like run it in my IDE here. So I can run unit test for test, and we'll just do it in here. If you do it from your IDE, it's important that you tell it to run inside your machine folder. So like the working directory here, it has to run from inside your machine folder. Otherwise it won't find like the machine configuration and it will complain. But if you got that, as you can see, it also works in my IDE. And now let's see how this works. So first I showed you we need balls in the trough, and that's what I did here. So as I tell it, hit the switch and run the machine. So hit the switch and run the machine for 100 milliseconds. And now I added like 6 balls. Let it settle for 2 seconds because like the troughs need some time to count the balls. And then like we assert, so that's important. So it's called self.assert and then something. And MPF has certain built-in assertions, and one is like assert the number of balls known. Now we assert that there are 6 balls known. It's often helpful to see if you like got some ball tracking issue, like if it lost track of a ball and there's suddenly 7, then something went wrong. So it's a good idea to just check that at the end MPF still knows the same number of balls. Then we say like, yeah, there shouldn't be a game running at the moment. I mean, it makes sense if the machine just started. And we hit the start button. Give the machine some time, so that's advanced time and run. It's like it virtually advances the time, and say for 10 seconds because it needs some time to feed the ball to the playfield and so on in my machine. And then we assert that that there's a game running. And finally, that's all what I did here is like I check that there's 1 ball available on each of the 2 playfields of my machine. And now I already showed you that this test case passes. We can also use -v, and it will show you like the log of the machine. As you can see, that's a lot of stuff here, but it's very useful. So like you see now that my machine is doing a lot of stuff during eject. So like the ball left, and it waited for the ball to settle, and eventually, yes, ball save that expired. And then we are done here. So that's basically after 12 virtual seconds. So you see the real time here, and this row here, that's basically the virtual time. So you can see after 10.5 seconds after the start of the test. So it starts always with 0. So and now we scroll up a lot. You can see like the time, right? 0, that's where MPF started. and 0.8, that's like here, those are 6 times waiting for 100 milliseconds plus 200 milliseconds, because that's the time for the switches to settle. So after 800 milliseconds here, it added the ball, basically. So it did the ball balance. Then we waited like another 2 seconds. So we should like be at 2.6, right? So because 600 milliseconds plus 2 seconds, 2.6 seconds, and so on. It adds up at the end. So next is like 10 seconds here. And so at the end, we are like at 12.6 seconds in virtual time, and 1 millisecond, which is probably a rounding error somewhere. So that's basically the simplest test you can have. Now we can have like a look again at the display field. And what we want to do is like we want to shoot this orbit here. So let's switch S orbit left front 1 and 2 probably, yes. So what we would do is like we do not want to activate the switch, we only want to hit it and release it. So there's like three methods. It's only hit, switch and run, hit and release switch. And there's also like release switch. Makes sense, right? And we want to hit and release switch. And now we do like S, and I forgot already. S orbit left front. Orbit left front 1. Then we advance time for like 100 milliseconds, because the ball needs some time to travel to the second switch. And now we hit the second switch. And let's give it another 100 milliseconds. It's fast, but doesn't really matter. And now we can basically look at how I'm counting my mode. So what do I got? I got some counters, as you would probably imagine. I got quite a few, and there's like left orbit shot qualify front. This one, default value 0. And now what we would do is like third placeholder evaluate to a certain value. So before that, we want like devices counters. And now I need the name again. Copy it. That would be cool. Good. Left orbit dot qualify front, and then we can see here in the monitor it's like dot value, right? And now we want to see that this value is before that sequence, the value should be 0, and after this sequence it should be like 1, because we hit it once. Now we can see if I was right, and no. Missing variable device. Default device counters, and yes, perfect, it's happy. So that actually happened, and now let's see if we can do it again. So we want to like shoot this like 3 times. Second time counter should be 2, and then third time it should be 3, I guess. Oops. See if that actually happens. It might just reset at that point. And now yes, and the value is none, because like this completed, this counter completed and got disabled at this point. So if we look at the machine, we will see that like there's like a mode starting there, and that's something we can also check. Like we got like modes and that should be yeah, now I need to find out how it's called. Qualify to left orbit. There it is. That's basically the mode which will start. It's left orbit front. And now we can basically assert that again. So we can say like here, self assert mode not running, and remember stuff, left orbit front. Left orbit front. And now after we made the shot, I mean, then it should be running. So now third mode running. See if I was right. And indeed, it hasn't been running and now it's running. There's also something else which is happening in my machine. And there's basically a qualify mode. And this qualify mode, that should stop, I guess, because you cannot qualify for another mode when one mode is like running, and it's called qualify front. And now we can check that like before here like is mode running, qualify front, and once I started this my orbit mode, this mode should no longer be running, so it should be stopped. And that's basically how you can then test your stuff. Now we can like intentionally break it if we want. Let's see, for example, if we go into the qualify mode and just change so like there's a lot of counters, and this one is like the counter which we just tested, and it has a complete value of 3. And now we can, for example, change to 4, and let's see what happens. We run it. Now it's complaining that that basically this didn't happen, that this mode didn't start and the qualify mode is still running. And it gives you even an error what it expected and which modes were running. There are like a lot of modes running in my machine. And we can also do it the other way around, so we can change it to 2. So it should start earlier. And if we run that, it will also fail, and because like the placeholder is not 2 in this line, so that's also working. Or like the test is also like showing that my mode broke for some reason. And that's basically how you unit test your machine. So it's actually that's simple. I mean, you can assert on simple stuff. You can also like look for events if you want. If you're looking at the event view here of my machine, you will see that there are like a lot of events ongoing. And you can also assert on certain events. For example, we can, instead of checking that this mode here is running, we can also check like on the event where it started. So there should be like an event which is called like mode started. And what you need to do here is like in the beginning, you do like self mock event. And the event is like mode left orbit front started. And the reason for that is that this basically registers an event handler for you, for your test. And what even has nice documentation. So you can read it. And it basically registers an event handler because otherwise it wouldn't know for which events it should look. And now we can say like, for example here, we can now say self assert event not called. And now we can say, well, at this point, we do not want this event to have happened since we mocked it. And at this point here, we can even repeat it, so it shouldn't have started here, and here it should have been called. Let's try it here. And that didn't happen because I still had it changed. See? And this actually happened. So the event got called here. We can even say I want to have it called with certain parameters, so we can do like event called with, and now it will have a look at the parameters, and apparently there are none for this event. Let's see if we got like one event with parameters. For example, I don't know. Yeah, I mean, you can basically assert on those parameters if you want, and that's sometimes useful. Like you want to, for example, see that ball search fails or something happened here, or some shot timeout or something. Doesn't really matter. Personally recommend like this placeholder syntax because that's super stable. Even if we like refactor MPF, those placeholders they will stay the same. And like you can also do the same with like asserting on code. So we can do like assert equal. Just showing you this. It's like self machine counters, and I put the name here of this counter. And now I can say, well, get start value count. So I basically can call into the internal code of MPF, and that should also work. Let's see. No. Did I use the correct one? 74. Yeah, apparently it's. That increases the count. So we can probably also do that. Like as a state, and it's called. That's basically value. So we can do that. But then, I mean, that works, as you can see. Now, but then, I mean, we might like refactor the code on how this works internally, and then like your test might break in a future MPF version. Because there's like no stability guarantee on like how the code is organized internally. But we try to keep those placeholders very, very stable and do not change them, because that's also which you usually use like in conditional logic for your events. And so that's basically, that's doing almost the same. Those tools are always doing the same, but I would always recommend to go this route for accessing internal state of MPF. Yeah, like mocking events is always very, very helpful. And then that's basically what you want to do, like to test any logic in your machine. And now I could like go on and test all the other shots and check that the modes are also completing and so on. So, but I think you get the idea of what this is doing. And yeah, that's basically what I wanted to show in my machine. If you want, we can look like a test, like a sample test of match mode. Are there any current limits which MPF testing with MPF testing that people should be aware of? Not really. You can do like anything. Like there's one thing where you should like have to be a little bit careful is like if you want to test randomness. So if you got like you got a random mode starting in your machine, then that will also be random in your unit test. And there is like a way to handle that, and that's basically by mocking randomness. So that's a little bit tricky, but it can be done. So like it's like randomizer. So No, we don't do it here. Test random event player, probably. Now we only test it a lot of times and see if it's random. Nice. It's also a way, but you can also like mock randomness. So I think we do this in tests in a few places. But that's like, it's not deterministic, right? That's like a small limitation we got, which can be worked around, but you just have to think about it a little bit, right? Even, for example, if you start a random sound, that's also like similar. And then if you would assert on a certain sound is played, then this is also random, and that wouldn't be a good test. So often it's easier to then test that a certain event is posted, which would trigger that sound, because that's actually what you want to know. But besides that, you can test like your whole machine. So if you look at MPF itself, we test basically everything exactly this way. So for example, for test match mode, we got like a test in MPF, which tests match mode. And we can go into that and here we go. And let's look at the configuration. So there's always like a configuration folder for the tests in MPF. And for the match mode, it would be here. And for example, for this test, it would be test service during high score. It's not a good one. Test no match. Here you can see it, for example. Here, because like the match mode contains randomness, there's like a way to, well, this random generator, pretend it just returned 50. And because like we get a random number between certain, between, I guess, probably like between 0 and 100, or 10 and 100. And yeah, we just pretend it's 50, and the score is like 37 at the end, so it's not a match. And that's what you do for like handling randomness in your tests if you want to do that. So this is basically the test mode, and we got like this configuration that has, okay, it has only one ball per game. It has credits turned off, turned on, so it makes sense to have credits on for match mode, sure. And it has two modes, the match mode and the credits mode. And I guess the credits mode doesn't really matter. The match mode has two very creative slides here, which both show ASD. And it has, it will show those two slides. What does it do? So first we got an event to add a credit. Yes, that makes sense. Otherwise the game wouldn't start. We check that the machine variable is also something which might be useful to check like machine or player variables. There's an assertion for that we got like 1 credit units. We start the game, the credit is gone. We add like some score here, so you can do that. You could also, it would be like even a little bit better to use like post an event here and use like something like variable player. So now we can also run this one. Now it's not running this one. So yeah, it passed. And we add some score here. We mock two events that there's no match and there is a match. Then the random hack, which I just explained. We drain all balls. That's also something you can do in certain tests. So you probably wouldn't do that in your machine tests, because there you would just put it in this trough, activate the switch. But there are some helpers for a lot of stuff. Once the time, so virtual time goes on. We check that the game is stopped. And we check that this event, that there's no match, has been called, and the other one event has not been called, and you didn't gain a credit. That's what we test on the match mode. And now we could, for example, break the test by adding like 50 at the end, I guess. that would then break. No, it doesn't. Interesting. I don't know. I don't know what it actually does here. So might do something else. Yeah, let's see what it. Okay, the return. Okay. So apparently, if the random number generator has 5, it will fail. Yeah, and now we got a match, and it complained that this isn't the event which it got, and this is the event it got now. So I hope that makes sense how this works. If not, please ask. That's basically how we check match mode. In general, you can have like multiple methods. So this is basically one test, and this is basically another test. And in each of those methods, have to be named test underscore something. You get a fresh machine, and it's all on new. So it will throw everything away and start a new machine for every test. So here, for example, we got one we do not have a match, and we got the next one where we got a match. It's basically exactly the same, except that this random number generator gets you 5, which I don't know how the logic internally works, didn't check it, and then provides a match for 37. And yeah, we do exactly the same, except that we now assert that this match event has been posted and not the other one, and we check that you actually got a new credit at the end. So that's hope that answers the question on the match mode. Let me know if you want anything else. I mean, if you want to see those tests, you can. Those are basically part of MPF, so we can. We can look at that. So if you just go to GitHub and open MPF, there's like a test folder here. And inside the test folders, there we got all those tests for all the devices we got, all the modes. We try to test everything. And with each of those tests, there's like a folder up here, which is called like machine files. That contains like the configuration, which is referenced in the test. For example, if you check achievement tests, it says, well, the machine path is test machine files achievement. And that would be test machine files achievement. And here you got like your normal MPF machine folder. And that's how we do it in MPF. And your machine tests work very similar for your machine. And that's how we test achievements, for example. You can look it up, and that's all possible. So that's basically the simplest way to test stuff. Yeah, and I mean, you probably noticed that there's no MC window or media controller window spawning up here. So this is running without a media controller. There are also like tests with machine control, with media controller that also works. Then you can also assert that certain stuff is shown on slides. That's also possible. Is it possible to reuse logic across multiple tests, such as the repetitive setups or teardowns? Yes. That's possible. You can use, like, example, if we want to say this stuff, like putting stuff in the trough, we can put this into a helper method, like let's call it setup trough, and we just copy all the code to this method and call it with self setup trough. And now it should hopefully still work. As you can see, this method is not named test, and therefore I cannot click it, I cannot run it. And now happened what I told you before. The machine path is wrong, and you get this error message. And now we can run it again. And now it still works, right? So this is basically the message. Can unit test work with monitor and media controller? They can work with media controller, but not with monitor. At least not at the moment. So the monitor won't work at that point. So I guess you would want that for debugging reasons, right? I mean, it's a good idea to just show it. It would be possible. It would be possible to add that. But currently it's like, if you look at this test case, what we do is like we disable the BCP, that's the Backbox Control Protocol, and that is what we use for like communicating with the monitor. And that's disabled in test because it would slow stuff down. You can test shows. Shows run in MPF, just like the slide portion. That would be in the media controller. And there's like I think it's called MPF MC machine test. I think it's integration test case. I think that's called. That's a machine version of it. Just have to check the right. I think I want like this. And now I want to add this integration test case. And let's see. Didn't test it before. Ah, yeah. I probably have to run it here. Yeah, I didn't prepare that, as you can easily see. Let's see if we can get it running. I did that before, I'm certain. It's called full machine test case. Okay. So let's try that one. So it's full machine test case, and then you get the MC also. And you will see that in a minute. Hopefully. You can see that it's a lot slower because it actually starts the media controller here. And even especially with my machine, it took like 13 seconds for the same test case because it loaded all the assets, started the whole machine. You probably didn't hear it, but I heard the music playing for a few seconds. And now we can basically test everything. So that's possible. So if we look at the machine again, let's start it again. So we can have like a look on what do we see on a certain screen. So stop the monitor probably. So now it says yeah, it's attract mode, balls, at a game. And now it will show, for example, 0, 0, right? The screen will show 0, 0. And we can now check that this is the case in our test case. So that's possible. So yeah, and let's see if we get score actually. If that gives you 1000 points. And we can now check that this actually does that. So let's see how we do that. So we start a game, that's done here. And now we want to see a third slide. Now text in slide. and the text is 00. That's what it shows. And the slide name would be something I have to look up because can we actually check that? Maybe there's something to assert text on top slide. Yeah, perfect. That's what I want. And now in my machine it's a little bit more difficult because I got a lot of displays and we have to check the right display here. And that would be slides probably. And the source display is DMD front. So on DMD front it should say 00. And after like the first round of the shots it should be 1.00. We can also like assert player variable equals. That's not so easy in my machine. Usually you could just assert on the score here, but in my machine you can't because there are like 2 scores which attract a little bit differently. But let's see if that actually works. So now the machine starts up here. You can see the 00 and on running 1000. Okay, and it asserted, okay, yeah, because I said a dot instead of a comma. It now complains in line 47 that there's like 1.000 instead of 1 comma dot 000. And that failed. So we can now change the test here. That's line 47 and run it again. And this time hopefully it should succeed. So that would be like, yeah, that's basically a test with included assertions on slides. That also works. And it passed in only 12 seconds. I mean, the reason for that is a little bit that if you run like the MC, it also tries to like time warp, but it cannot in certain cases. So if you got like some animations running, that will basically slow down the tests to about real time here. So that's a disadvantage of running like tests with the media controller. It's a lot slower, but still it does it fully automated for you. So it's better than clicking this manually. Because if you do like all the tests with media controller, that will be probably slow. Any other advice on performance or testing to keep it fast? Just run it without media controller. Usually, I mean, the media controller slides are usually just triggered by some events. So assert on the events which would then show on the media controller, and that way you keep them fast. So like we run like, I don't know, 700 unit tests or something in MPF, and they run in like 17, 18 milliseconds on my machine. So it's, if you just test logic, it's relatively fast. We test it. Yeah. If testing is not enough, like before like bringing a machine to production, I usually like recommend to run like some fuzzing on it. That would be like, I mean, if we look at my small slide again here, if we look at this, basically fuzzing works exactly the same way, except that those inputs are not manually written by you, but by a program which automatically generates those inputs and tests certain outputs, usually that it doesn't crash. Also that, I don't know, balls are not lost or something else. And that allows you just to test, to systematically find crashes. That's also something I would recommend before going to production. But double test first and do fuzzing at the end, because it makes no sense to do that before your rule sets is 99% finished and programmed. So that would be my advice on that. But generally, just have a few tests. Do not make them too complicated. Keep them simple. Another thing, which is like general advice on tests, not just in MPF, is do not test the same thing twice, if not possible. So, like, for example, we now did like refactor this drop setup into a separate method. That's okay to use that, but if you copy and paste it everywhere and you change it later, you have to fix all the tests, and that's not nice. So it's usually a good idea, if possible, do not repeat stuff, and if you repeat it, put it into a separate method so that you only have to change one place if you change it. But besides that, tests are a good idea. Yeah, I guess that's from me. We got like 1 hour filled. If you got questions, please still ask. And if not, I would wrap it up and have this like as a small tutorial on the documentation later. So you know part of the documentation of MPF. And yeah, thanks for joining in. Thanks for asking questions. I will be back on Saturday, probably on steppers. I will show like the Pololu stepper controller. I forgot the name. And yeah, we will play some steppers. Maybe we'll also play with like the PD LED. Maybe I will also wire that up. And yeah, we will have some fun with steppers. There will be a new tool of the week, which I still have to select. And until then, I wish you like a great week. Have fun hacking pinball. And see you soon.